Welcome to PC 101. Today we are going to go through homework number 30. In this tutorial we're going to help you balance equations, identify types, identify who says Leo and who says Gur in redox reactions, and solve some mole problems. Today we're going to look at the answers for 1b, 3b, and number 6. These are all based around one chemical reaction, a chemical change. Aluminum reacting with hydrochloric acid, HCl, forming hydrogen gas, and forming aluminum chloride. If I take a look at this equation, the first thing that I note is that this is a single displacement reaction. Single displacement, SD. Because an element, aluminum, kicks out hydrogen, forms a new compound with the chloride, forms aluminum chloride, and the hydrogen goes home alone, forms hydrogen gas. This is a single displacement. Element and compound make element and compound. It's also a redox reaction. And in redox reactions, electrons are lost and gained. In order to figure out who loses and who gains, who says Leo and who says Gur, who's being oxidized, and which element is being reduced, we need to use our ion sheet plus some knowledge taken from one of our previous lectures. Recall that all free elements have a combining capacity of 0. So atoms all by themselves, aluminum, this just represents atoms of aluminum all by themselves, uncombined with any other element, have a combining capacity of 0. Over here I've got hydrogen gas. That is an element. Uncombined with any other element, its combining capacity 0. Next, I might use my ion sheet if I can't remember these, and I look at my ion sheet, and here in hydrogen chloride, I see that H is +1 on my ion sheet, and chloride is -1. And I go over here, and I find for aluminum, aluminum is +3, and chloride is -1. Now, what I would like to do next is determine for number 1b, who says Leo and who says Gur. So first of all, we'll take a look at the aluminum. The aluminum is a metal, and aluminum starts out as a free element, 0, and becomes aluminum ions, a cation. Here's deficient 3. Because it's a metal, recall from your lecture on the periodic table that metals like to lose and become cations. Well, if it loses electrons, it undergoes the process of oxidation. Aluminum says Leo. Lose electrons, oxidation. The aluminum's been oxidized. In fact, in chemical reactions with free metals, they typically form cations because that's what they do, that's their chemical property, and they're oxidized. Look here at the hydrogen. The hydrogen's +1, so its combining capacity changes and it forms hydrogen gas. Its combining capacity is 0. To go from +1 to 0, its combining capacities changed. In fact, it's actually smaller. It went from +1 down to 0. It was reduced. To go from +1 to 0, it had to gain electrons, so the hydrogen ions say Gur. Leo says Gur. This is a redox reaction. Aluminum is oxidized, and the hydrogen ions are reduced. Now, if we move ahead to 3b, 3b asks us to balance the equation and then to fill out the chart that we've done before as part of the lecture and another homework, number 27, in terms of determining the ratio of the moles and the masses. So in a way of reviewing how to balance, remember the big goal is to get the coefficients. Those are the big numbers that would go out in front and sit on those lines in front of the symbols and formulas for elements and compounds. Hesse hint says start with the first element of a big chunk. Well, this is the biggest one, and aluminum's number 1, so I'll start there. In my products, I have 1 atom of aluminum, and I have 1 atom of aluminum in the reactants. Stay within compounds, that's another hint. I've got 3 atoms of chlorine, and over here, I've got 1 Cl in HCl, so I'd have to put a 3 in front of the HCl. That gives me 3 Cls. Now, I've got 3 H's. But the problem is, on the product side, I've got 2 H's. So I'm in trouble. I mean, I got 3 and 2. I mean, one's odd, one's even. So I have to look some way of figuring out how to get the same number on both sides. Well, when in trouble, double. and we double what's giving us the trouble, and this would be the HCl's, because I've got 3 H's, and I got to get an even number. So if I double 3, I get 6. That gives me 6 H's, 6 atoms of hydrogen. And if I were to put a coefficient of 3 in front of the hydrogen gas, that gives me 3 chunks of hydrogen gas at 2 H's each. 3 times 2 would be 6 atoms of hydrogen. Now they're balanced. But the 6 in front of the Cl's, now that I got 6 atoms of chlorine, and I need 6 in the products, so if I were to put a 2 as a coefficient in front of the aluminum chloride, that in turn would give me 2 times 3, or 6 chlorines. Note also that it changed the aluminum, so I got 2 aluminums in the products, and if I make 2, well, I certainly better start with 2, so I should put a 2 in front of the aluminum on the reactant side. So here I've got my balanced chemical equation. Now recall that the balanced chemical equation gives me information at 3 levels. It tells me the ratio of how the atoms and molecules react at the atomic level. So this says that 2 atoms of aluminum will react with 6 molecules of hydrogen chloride to make 3 molecules of hydrogen gas and 2 formula units of aluminum chloride. Now remember, these are all little particles, but an atom is the smallest portion of an element that can still be said to be that element. And that would be, for aluminum, would be an atom of aluminum. The smallest portion of a covalently bonded compound, typically 2 nonmetals, would be a molecule. So I've got 6 molecules of HCl, producing 3 molecules of hydrogen. And the smallest unit of an ionically bonded compound that lives in crystals would be the formula unit. Since aluminum chloride is made up of a metal and a nonmetal, anion, cation, it's ionic, the smallest portion, the simplest ratio of the ions in the crystal would be AlCl3, and that's called the formula unit. Well, the nice thing is that the ratio of the particles at the atomic level give me the ratio of moles at the macroscopic, the handful level. So this says if 2 atoms react with 6 molecules, then 2 dozen would react with 6 dozen, and 2 moles of aluminum would react with 6 moles of hydrogen chloride to make 3 moles of hydrogen and 2 moles of aluminum chloride. But of course, all these moles have masses. Each mole has a mass. Remember, it's its gram formula weight. It's the weight of the formula in grams. And how do we get this? Well, we go to the periodic table and we look up the atomic weights. So when we talk about the math level here, and we make 2 moles of aluminum, that's going to be 2 times 27 grams, because that is the atomic weight of aluminum. 2 times 27 is 54 grams of aluminum that are going to react. And I have 6 moles reacting with 6 moles of HCl. Now, what does HCl weigh? Well, hydrogen on my periodic table weighs 1, and chlorine weighs 35.5. So if I add this up, I get 36.5 multiplied by 6, and I get 219 grams. And this then produces hydrogen gas. Well, how much do I make? I make 3 moles. 3 moles of hydrogen gas. Well, let me see. 3 moles, and each hydrogen is 1, and I've got 2 atoms of hydrogen, so that's 2 times 1 or 2. So that would give me 6 grams. 6 grams of hydrogen. And it makes 2 moles of aluminum chloride. 2 moles. Well, let me see. Aluminum chloride, AlCl3. Aluminum on my periodic table weighs 27, plus 3 chlorines. Chlorine is 35.5, so it's 3 times 35.5. Okay. I take these, I multiply by 3, then I add on 27 and multiply by 2, and I get 267 grams. So this tells me that if I react, and everything goes just perfect, that if I react 54 grams of aluminum and 119 grams of hydrogen chloride, I can make 6 grams of hydrogen and I can make 267 grams of aluminum chloride. So that's how I'd work my way through 3B. Now let's take a look at number 6. Question number 6 says, if you started with 10 grams of aluminum, determine the mass of aluminum chloride that you could produce. So here's the deal. And I'm going to change the color of my pen up here. I'm going to change to blue. Here's the deal. According to my balanced chemical equation, 54 grams of aluminum, 54 grams of aluminum will make 267 grams of aluminum chloride. But here's the problem. I'm not starting with 54 grams. I'm only starting with 10 grams. So the question is, if I start with 10 grams of aluminum, how many grams of aluminum chloride can I make? Well, to do this, we're going to solve it by a proportion. Remember, there's 4 ways to solve math problems in science class without doing calculus, and one way is a proportion. So what we're going to do is that we're going to set up the proportion between aluminum chloride to aluminum. And here's what we're going to do. We're going to take the numbers from the equation. We're going to take the equation grams. And we're going to say, look, if I can make 267 grams of aluminum chloride when 54 grams of aluminum react, according to the equation, if everything goes just perfect. But I don't have 54 grams. I want to know how many grams of aluminum chloride can I produce if I start with only 10 grams, a little bit less. Again, a proportion is 2 equal fractions. So whatever goes on the top of the fraction and the bottom on one side, you have to have the same words on the top and the bottom on the other side. So if I can make 267 grams of aluminum chloride if I start with 54 grams of aluminum, how many grams can I produce if I start with 10 grams? Notice there are 4 possible numbers and we know 3 of them. To solve this, all we have to do is to cross multiply. So we get 267 times 10 divided by 54, and that is going to equal x. And if I do the math, multiply by 10, divide by 54, x turns out to be 49 grams of aluminum chloride. So if everything goes just perfect, if I started with 54 grams of aluminum, I could make 267, but I don't. I've got 10 grams. If I start with 10 grams, I can make 49 grams of aluminum chloride. All the rest of the problems are identical to this. Same approach, different equations, different numbers, but it's the same approach. We hope that this helps in figuring out how to do homework assignment number 30.